This multiple choice question is about mass spectra. Now, it's not a particularly difficult question in terms of we could just add things up and work out the answer. But let's see if we can get like a way to work out the answer relatively quickly. So one thing I might assume is that the biggest number here is the mass of the whole molecule. And I would be right, 178 is the MR. But another really good strategy for when you've got a big molecule like this is to draw it out in terms of what it could break down into. So at the top I've got 2 methyl groups which have a mass of 15. I mean, we could lose hydrogens anywhere on the molecule, but that's not really going to give me any information because it's just going to be one less than the molecular mass. I've then got a carbon which is going to have 1 hydrogen attached, so that's going to have a mass of 13. I've got a mass of 16 for that oxygen. Now C double bond O's don't normally break, so I'm going to write that whole thing as 28. So that's a C double bond O group. And then I've got another carbon which has got 2 hydrogens attached, that's going to be 14. And then a benzene ring. So benzene ring isn't going to break up in a mass spec. It's a very stable delocalized system. So what you're going to get is the formula C6H5, because remember we've taken a hydrogen off to attach the carbon to it. So C6H5 has a mass of 77. So straight away I can work from the outside in. I can add all of that up and find that it equals 78, so I know that's in there. For 43, I'm going to look at the far end of the molecule, not the benzene ring, because 43 is a low mass. And actually, if I work out 15 plus 15 is 30, plus 13, that is 43. So that is present. 103, well, if I start at the benzene ring end, I've got 77, 87, 91 in this bit. Oh, I found that fragment there. Let's just check if we can find 103. Well, I can't then go on to CO or even just C, because then I'd be adding 12 onto 91. It doesn't really work like that because I'd have to break off the C double bond O. So no, I can't really make 103. Another way to look at can I make 103 is to see if you can take away from the molecular mass. So 178 minus 103, because it's easier to look for smaller fragments than it is to look for bigger because there's less adding up. So that's going to be a mass of 75. That's what I'm trying to find. So can I break off a mass of 75? Well, I've got 43 at the top. I keep going down to 16. That's 59. If I add in the 16, and again I've got this C double bond O, which isn't going to break in a mass spec, or highly unlikely to. So that's why 103 is my answer.